Okay.
it okay?
Yeah.
Yeah.
Could you enlarge or make the full screen mode? Is it possible to change to the full screen mode while enlarging the slide?
Unfortunately, I don't know how to do it.
Okay. Let's go to this way. Yeah. Okay,
Okay. So hello to everyone, and first of all to my old friends and colleagues. Glad to participate in the Exactly 2024, even remotely online. Is Alexander Borisov, Sasha. I am of the Lebedev Physical Institute, Moscow. The title of my talk is The Complex Nature of Abnormally Weak Absorption of Cosmic Ray Hadrons in Lead Calorimeters at super high energies. I'm sorry for my voice. I can't speak louder as I caught cold. I present the results of the studies of scientific group that conducted X-ray emulsion experiments at mountain heights, in particular in the Pamirs and Tian Shan. These specific researches deal with the puzzle of so-called long-flying cosmic ray hadronic component. As is known, this component was first observed in an experiment with large ionization calorimeter at the Tian Shan Mountain Research Station back in the distant 1973-74 years. A similar phenomenon was observed in the 1980s in the Pamir X-ray emulsion experiment, where deep uniform lead chambers 110 centimeters thick were exposed for several years. Sorry. So this is the slide with large ionization calorimeter, the scheme of the calorimeter, and this figure, you can see the attenuation length of hadronic component in EIS cores observed with ionization calorimeter. So you see the rise, and simulation couldn't explain the experimental results. So this is the experiment of deep with deep uniform lead X-ray chamber, 110 centimeters thick, and you see at the depth of this chamber we observe some excess of hadrons, which was rather extraordinary. So very soon a hypothesis was put forward about the existence of some unknown long-flying hadronic component of cosmic rays, and two plausible candidates were proposed to explain the nature of this component. One proposal was the essential contribution of giant particles, and alternative hypothesis is manifestation of quark strange matter, existence of strangeness. We designed, at the time we designed a new type of X-ray emulsion calorimeter with 2.5 air gap between two lead blocks. In this air gap, we were going to be expecting we observe the decay of the charged particles, and the absorption curve will be somehow of this type with this electromagnetic peak. This talk presents the results of joint analysis of data from two closed experiments in which this talk presents the results of a joint analysis of data from two closed experiments in which the same type of two-tier lead X-ray emulsion calorimeter with a large air gap was exposed at mountain heights. In an experiment carried out in 2007-2008, the Tianshine at the Tianshine station at an altitude of 3,340 meters above sea level, and an X-ray chamber with an area of 48 square meters and an air gap 2.16 meters with a total thickness of 50 centimeters absorber was used. And in an experiment conducted in 2011-2012 in the Pamirs at an altitude of 4,370 meters above sea level, an X-ray emulsion chamber with an area of 36 meters and air gap 2.5 meters was used with a total thickness of 67 centimeters lead absorber. The schemes two-tier X-ray emulsion chambers are presented the area of the as I told you, the area of the upper block block of both chambers was slightly larger than that of the lower one, namely 32 square meters and 24 square meters respectively, which made it possible to cut off background particles with large Zenith angles arriving at the lower block of the installation by passing the upper one. Background suppression was also carried out due to the fact that the assembling of cameras began from the upper block, while disassembling always started from the lower block. To analyze the data from both experiments, detailed Monte Carlo simulation of the development of hadron cascades in X-ray emulsion chambers, as well as the response of the two-tier X-ray emulsion chamber, was carried out. We applied a new technique of X-ray emulsion data processing in the case of analysis of hadron absorption in lead calorimeters. Conventional technique of the Pamir experiment includes reconstruction of hadronic cascades in the X-ray emulsion chambers, applying this, the photometric procedures performed on microphotometers with diaphragms of radius 84 microns. New technique selects and counts of only individual darkness spots on each field of a given observational level by a naked eye, enhanced by only glass. Advantages new technique were proved by simulations. They are the following. Provide high sensitivity to determining our absorption curve parameters, increases the statistics of experimental data, does not imply conventional photometric procedures, which is especially important given the uncertain sensimetric characteristics of new X-ray films used in this experiment. Makes it possible to avoid ambiguities related to the reconstruction of the hadronic cascades, more stable to the systematic errors. Note that our analysis showed that the selection criteria for dark spots in the experiment give the same result as the simulation if we select spots with optical density D1000 greater than 0.04 measured with a photometer diaphragm of radius 1 millimeter or 1,000 microns. So this slide presents the comparison of three sets of simulated data on absorption curve at different thresholds of optical density D1000, 0.04, 0.02, and 0.1 with respect to experimental data measured with naked eye. You can see in this figure that the position of the electromagnetic to the right with the threshold of optical density D1000 increasing so that maximum of simulated peak practically coincides with experimental one. Next slide. Sorry, no problem. Next slide demonstrates the sensitivity of two-tier X-ray emulsion chamber, namely Tianshine calorimeter, to the charm production cross-section. Also, three sets of simulated data, but calculated on the assumption of different values of charm production cross-section are compared with the experimental curve. The best fit in this case is sigma equal to 8 millibars per nuclear. Next slide. The same comparison as on the slide 10, but for the Pamir two-tier X-ray emulsion chamber. You can see there also the shift of the electromagnetic peak with optical with threshold of the optical density. Here you can see the combined results of exposition of two-tier X-ray emulsion chambers at the Tianshine and Pamirs in comparison with model calculations. So you can see a rather good fit of experimental data by simulations on the assumption that cross-section, the charm production cross-section is about 8 millibars per nuclear. All is good, but you see the, please look at the extreme left, right points in this figure. I mark them with red circles. They're quite extremely far from simulated data. One can see a striking difference of experimental simulated data on absorption of hadrons in LED absorbers. To explain this success, we need to involve additional factors, sources that may contribute to abnormally weak absorption of hadrons at great depths. For instance, the existence of strangelets emitted by strange quark stars or beams of high-energy direct muons generated by jumped hadrons in the atmosphere. I
Okay,
will
Sasha,
skip.
you have only 2 minutes left.
I will skip this slide due to the next slide. Presents a comparison of our cosmic ray experimental results on the charm production cross-section with those from accelerated experiments near the RIC and LHC. You see our data is above this curve, accelerated curves. So conclusions. The nature and position of the features of the absorption curves obtained in both experiments with two-tier X-ray emulsion chambers and as a result of model calculations are in a good agreement with each other, which indicates the correct interpretation of the experimental data as the observation of the birth and decay of chunk particles. Calorimetric experiments in cosmic rays with two-tier X-ray emulsion chambers are rather sensitive to the cross-section for chunk production in the forward cone, which is not accessible for observation in collider experiments. Chunk production cross-section in the forward kinematic region we estimate is as high as sigma production equal to 8 millibars per nuclear. The excess of hadron cascades in the depths of lead calorimeters can only be partially explained by the contribution of the chunk particles. Additional sources of this excess may be strangelets emitted by strange stars or beams of high energy direct muons generated by chunk hadrons in the atmosphere. So prospects of our activity researchers: upgrade of two-tier X-ray emulsion calorimeter by replacing the sensitive elements from X-ray film with extended plastic scintillation counters with fiber optical signals readout or ionization chambers. Continuation of researches at the Tianshan Mountain Station related to the study of the features and absorption of high-energy cosmic ray hadrons at great depths of a lead absorber using a two-tier scintillation ionization calorimeter. Thank you.
Thank you very much.
Thank you
So now it's time for questions. Any questions? No? It's also online. There is no question. Ah, okay, please, please. No? Okay, no questions. It's you can go ahead.
Okay. Dobry dzień, Sasha.
Dobry dzień.
I've just spoken with
Glad to hear.
Sorry?
I'm glad to hear you, Brian.
Yeah, spasiba. I've just spoken with Sunil, and we would like to send greetings to you today from all of us here at the Mexican Izvekri, and in particular from several of us here who have known you over so many years. It is good to hear from you after a long silence, and we hope that you will keep well and will keep in touch in the coming years. Thank you very much.
Thank
Good
you.
day.
Yeah. Unfortunately, the COVID was rather hard for me. Now I am coming better.
Okay, thank you very much. Yeah, thank you very much. So let's move to the last talk in the session. So thank you very much to the speaker again.